Hello students, welcome to Theory Maths. So today I'm going to be solving this question to find the value of a. Now solution. Now looking at this question, we are told that a raised to the power 1 over 4 plus a raised to the power 1 over 2 is equals to 1. Now to find the real values of a, what we need to do is to reduce this expression or this equation so that we can substitute. Now to do that, we are going to employ the knowledge of indices, where if I have x raised to the power n or raised to the power m, then it is the same thing as x raised to the power n times m. Now this law is vice versa. So what I'm going to do now is to have my a raised to the power 1 over 4, then plus, instead of a raised to the power half, what I'm going to have is I will make it a raised to the power 1 over 2, then 1 over 4, then it is raised to the power 2 is equals to, we have 1. So therefore, since we have this, let me write it 1 over 4 plus a raised to the power 1 over 4 or raised to the power 2, then is equals to 1. Then what I can do is to say let x be equals to a raised to the power 1 over 4. So what I'm going to have here now will be x, then I have plus x raised to the power 2 is equals to 1. Rearranging it, I'm going to have x squared plus x, then minus 1 is equals to 0. Now this is a quadratic equation that I need to solve. What I'm going to do here, because it cannot be factorized, I will employ the quadratic formula, which says that x is equals to minus b plus minus root of b squared minus 4ac all over 2a. Now, in doing this, I need to know the value of my a, b, and c on this note. Now, recall that the normal format of a quadratic equation is ax squared plus bx plus c is equals to 0. So I'll bring down the equation given to me. I have x squared, then plus x minus 1 is equals to 0. Now comparing terms, I can see that my a is equals to 1 because coefficient of x squared is 1. Then my b, of course, is still equals to 1, and my c is equals to minus 1. Now putting them back into the equation, I'm going to have my x to be equals to minus 1 plus minus, I have root of 1 squared minus 4 into 1 into minus 1. Okay, substituting it now all over 2 into 1. So therefore x will now be equals to minus 1 plus minus whatever is in the bracket will be 1 plus 4 all over 2. Now this will be minus 1 plus minus root of 5 all over 2. Now that is x, all right? But recall that x is equals to a raised to the power 1 over 4, all right? So what I'm going to do now is so we can say this is equals to minus plus minus, that is minus 1 plus minus root of 5. All right, but there is something that I want us to understand here. You see, a raised to the power 1 over 4 is either minus, of course, this is over 2. Okay, let me not forget. Now, minus 1 plus root of 5 all over 2, or minus 1 minus root of 5 all over 2. There is something that I need you to understand here. You see, the fourth root, which is an even root of any number, cannot be negative. All right? Since it cannot be negative, then it cannot be this. So we're taking this one out because that is negative and this is positive. So this is the correct thing. Therefore, we will now continue to say, okay, since a raised to the power 1 over 4 is equals to minus 1 plus root of 5 all over 2, then how do we get a? What you need to do is to raise it to the power of 4. So this to the power of 4 and this to the power of 4. Now, this is what I will have. I'm going to have that these 4 cancel this, so that I'm going to have a will now be equals to minus 1 plus root of 5 all raised to power 4, then all over 2 raised to power 4, which will now be minus 1 plus root of 5 all raised to power 4 all over 16. Now, having this, we are going to expand minus 1 plus root of 5 all raised to power 4. Now, I am going to use Pascal's triangle to get the coefficients. Remember, in Pascal's triangle, this is what we have. If the power is 1, of course, it's 1. When the power is 2, we have 1, 2, 1. If the power is 3, it's 1, 3, 3, 1. And if the power is 4, it's 1, 4, 6, 4, 1. Hence, what I'm going to have now here will be minus 1, okay, all raised to power 4. Then I'm going to have plus. I will now have the coefficient, which is 4. So I have 4 into, I'm going to have minus 1 all raised to power 3. Then I will have root of 5. Then I have plus, the coefficient is 6. Then this is going to be minus 1 all squared, the root of 5 all squared, then plus, I'm going to have 4, then minus 1, okay, then I'm going to have root of 5 all raised to power 3, then the last will be root of 5 all raised to power 4. Now, doing this, I'm going to have, this is 1, then I'm going to have minus 4 root 5. Then, of course, this is going to be plus. I have 6, then into 5. Then I'm going to have minus, not plus, minus now. I'm going to have minus 4 into 5 root 5. Then I have plus 5 all squared, okay? So this is 1 minus 4 root 5. Then I have plus 30. Then I have minus 20 root of 5. Then I have plus 25, okay? Bringing it together, I'm going to have minus 24 root of 5. Then I have plus, okay, that should be 56. So I have 56. Now I can rewrite it as 56, then minus 24 root of 5. Now, since I've dealt with this, then A will now be, okay, A will now be 56, okay, I have 56, then I have minus 224 root of 5, then all over 16. Remember? Okay, let me show you. Okay, so look at it. So therefore, you see, I can actually factorize 8 out, so that I'm going to have 7, then minus, I have 3 root of 5, close the bracket, all over 16. Then this one will cancel this, that is 2. So my A finally will be 7 minus 3 root of 5 all over 2. So this is my final answer. Thank you for watching, and do not forget to subscribe for more interesting Olympiad videos.